Welcome back to Calc. Okay. Um. So yeah, welcome back to calculus. You know, during quarantine, always fun. So we're gonna talk about antiderivatives or indefinite integration. I'm mainly doing this because I know I'm gonna forget about this in like the next couple weeks or days while I lose my mind in my house. So yeah, I just thought I'd go through a few problems that I thought were good to go through and understand kind of what we're doing. So like one of the most important rules that we're gonna need to like solve all these problems is this one right here. So it's basically saying that whatever exponent you have, you're gonna take the x and then add 1 to that exponent. And to the bottom, whatever number was that exponent, you're gonna add 1 to it too. So it's gonna create like a fraction. And then you're gonna add c. So this c right here is kind of important, or it will always be needed. So whatever answer we get once we finish these problems, you have to add the plus c. We add that since it's kind of a placeholder. So basically what we're doing here is every time we have a problem, we ask, what is the antiderivative of 2? Let's say that right. So for this first problem, it's going to be 2x plus c. So basically we're asking, what was this before this is basically the derivative, right? So we're going to ask, what was this before we took the derivative of? So we're basically looking for the original function. So this is what it was. As you can see, if we take the derivative of this, it would just be 2, which is that. Okay. And then we add the plus c because we're not really sure if there was a number there. It could have been like a plus 7, a pi. We're not sure. So we just need to add the plus c to, cover our ass. Okay. For the next one, we have 6x. So for this one is where we're basically going to start using this rule. Okay, so we don't have a number there, right? But we do. It's 1. So it's 6x squared over 2. And the reason I got that is because there is a 1 here. And if we use this rule, it'd be 1 plus 1. So it's the squared. That's where we get the 2. And then n, or whatever the exponent was, plus 1. So that's where we get the other 2. Okay. And then here, you simply simplify. You get a 3 there. And you just get the answer 3x squared. But we need the c. So it'd be 3x squared plus c. Cool. So those were easy ones because it was just kind of like one number. So when we start going to these like larger ones, we just need to integrate each number. And yeah. So that's kind of right. Okay, so for this one, you're really just using this rule the whole time. It gets kind of annoying after a while, but that's really all you're doing. So for this one, maybe 20x 3 plus 1, 4, and then 4 at the bottom too, plus 3x, you add the 1, and then 3 plus 1, 3. I mean 2, yeah, you get it. And then 5, I thought we would just put a 0, but that doesn't make sense because it's a derivative. So we need a 5x. You add your trusty c. There you go. Okay, so in here, we're just gonna, what's it called? Simplify. So 1, 5, just like that. So then for this answer, you would get 5x to the 4 plus x cubed plus 5x plus c. And you can check it, take the derivative of this. So it's 20x cubed, there you go, 3x squared, there you go, plus 5, there you go. And as always, we add that c. Okay, so for this one, yeah, this one's scary. Okay, so this one was actually pretty simple. We just need to rewrite it. So we need to rewrite it first. That stays the same. This becomes x to the 1/3 over 3 minus 6. Oh, geez, that's not rewriting it. This becomes 6x to the 1/5 over, I think, 5. Yeah. So that's just rewriting it. That's not really finding the integration or integrating any part of it. That's why I put the dx again, because it's just rewriting the problem. Okay, so the first part is simple. You would essentially just get 12x6 over 6, as we've been doing, just using this rule. Okay. So for the next ones, it doesn't really get challenging, it just gets to be more work. So what we do is kind of just do the 4/3 and then put it to the side. Not to the side, okay. I was gonna write it. 4/3, and then you're gonna do like a times, because now we're gonna work with x. Okay, now got my trusty journal. Alright, so then here what we're basically doing is the 1/3 we're gonna put into this equation, or this rule, right? Okay, so it'd be x to the 1/3 over 1/3 plus 1. So remember the rule, we're adding a plus 1. Well, since we're working with a fraction, we're going to need to use whatever that means here. So this is a 1, right? Like that's a 1. But since we're working with 1/3, the 3 essentially becomes 3 over 3, and that's a 1. Okay. Anyway. So the x becomes 4 over 3rd, 4 over 3 or whatever, and then this becomes 4/3. Right. So then what we do here is we multiply by the reciprocal, and then here in the bottom you can cross that out. Here you got to be careful. So we're not really, so this is the exponent, so this means that we're multiplying this 3/4 back into this original, where was it, right here, back into the original thing that we're working with, right? So actually, since I split it up, we're just going to put one more, and then that 3/4 comes back in here, right? And then we got that x was 4/3, so that's where we put the 4/3. Cool. Here you can tell, you can just cross these out. Cool. Okay, so let's just rewrite this one. Minus, since that canceled out, it's just x to the 4/3. Cool. Now we gotta work with this one. So, for this one, it was 6x. Oh, okay. So just do the same thing again. We're gonna split that up. 6 times 5 times x. We're gonna find out what that is. So it was 6 to the 1/5. So that means that our 1 is 5 over 5. Cool. That means that x is 6 over 5. All over 6 over 5. Reciprocal. Yeah, essentially you're always going to cancel these out. And then this one you have to remember, we're not going to multiply to this one. We're going to multiply to the equation, or this number that we split before. So it's 6 over 5. Oh, I'm sorry. Oh, jeez. 5 over 6. I hope you guys caught that. Okay, so it's 5 over 6. Cool. And the x, we have 6 over 5. So, nicely done. It cancels out. So we just bring it down, 6 over 5. And we're almost done. So basically here you just simplify. And the only thing that needs simplification is just this one. Cool. So you can just see, if we were to take the derivative of this, it would be 12x to the 5th minus, oh, that mama jumbo. And it makes sense since we're gonna, yeah, don't worry, that's what it is. And then we just add the plus c, ensuring that we know what we're doing. All right, okay, for this one, it was kind of a mix. I like this one because it was easy, and then it included that like last kind of hard part, but it's not really hard once you, if we already did this one, which is like the hardest one, it becomes easy. Okay, so for this, we're gonna take 8x4 all over 4, using the rule again, just adding that plus 1 to whatever that exponent number is, plus 10x squared over 2. Again, it's a 1 there. So you just add 1. Okay. I'm sorry. Then, okay. So we're just doing the same thing we were doing up here in the other ones. It'd be 21 over 4 times x. Okay. It's x 3/4. Okay. Again, since we're working with 4, our 1 is 4 over 4. 3/4 plus 4 over 4. That gives you 7 to the 4. 7 to the 4. Using blah 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 reciprocal. Boop. That gets rid of that. This is our x, and we need to plug that into the original or whatever. Or okay. Okay. This is the original I'm talking about. Like this number right here. So that's 4 7s. And the x, as we said, was 7 over 4. Cool. This right here, let's see, this is the 4's cancel. This 7 equals a 1, and 21 divided by 7 is 3. Okay. So here you honestly can just already simplify. So that'd be a 2x to the 4. So this becomes a 1, that becomes a 2. And then plus 5x squared plus 3x to the 7/4. Okay, now let's check. So the derivative of this, oh, I'm so sorry, jeez, plus c. Okay, the derivative of this, yeah, negative 8x cubed plus 10x plus, let's see, 21 over 4, yep, cool. And then you add your trusty c, and yeah. I could have explained that a lot better, but this is really just, you know, getting the basics. Anyway, take care.